In question 9, there's a lot of reading to get through. But for part A, you just need to explain that in that linear model, it says that high hours would imply high productivity. But the words said not valid. The word said that wasn't true. If you did too many hours, it would go down again. So we're looking at model B. And in model B, we've been told that the productivity is A lots of 16h minus h squared. Just being asked to find out what A is. And we've been given a point that we can put in, 896. So if we put the 96 in there, and we've got A lots of, stick the 8 in there, we've got 144, take away 64, 128, take away 64, so we've got 64A, and so that A is turning out to be 1.5. So then in part C, we're asked to say that we want the productivity to be at least 90. So we want 1.5 lots of 16h minus h squared to be greater than, at least, greater than or equal to 90. Well, if we divide both sides by 1.5, then we're going to get 60 here, aren't we? And then if we drag all that over to one side, we can get 0, 16h and a 60 there. Should we do it on the calculator? I mean, I'd factorize it myself, but if we do it on the calculator here, we're going to our inequality solver, degree 2, and we want this is less than or equal to 0, so that's number 4, and we've got a 1, a minus 16, and a 60, and that's telling us that h can be between 10 and 6. Finally, in part D, comment on how realistic each model is in the following cases. If h is equal to 0, so if you did no hours work, then you'd get no productivity. Yeah, that sounds good, doesn't it? If you didn't work at all, that's fine. But if h is equal to 17, then the productivity would be negative. And I think I might even tap it in and find out what score I got. But it's obviously, therefore, not realistic here.